Welcome to Pre-Calculus Section 6.4 on solving log equations. The first thing we're going to do is see how many ways we can think of to rewrite an equivalent form of 5 times log x to the negative 2/3 power. So the first thing I can think of is I could take my power and, using the power property of logs, put it out front and multiply it by the 5. In that case, you'd get 5 times negative 2/3 log of x, which is equal to negative 10/3 log of x. Or you could take the 5 and put it back up top to be with the negative 2/3. So we would get log of x to the negative 2/3 times 5. So that would be log of x to the negative 10/3, where it's up there. The next thing I can think of is we could actually take that x to the negative 2/3 power and call it 1 over x to the 2/3 power. Then we could take that x to the 2/3 power there and write it in radical form. So I'd have 5 log of 1 over the cube root of x squared. And then while we're at it, we could take that 5 and put it back up at the top again on this form. So we'd have log of 1 over the cube root of x squared raised to the 5th power. Or we could go off of this one here and put that 5 back on top again, so we could call that log of 1 over x to the 10/3 on the bottom this time. So this is an exercise we can go through with any log expression. We can think of as many ways that we can rewrite it in an equivalent form for practice. So they're very versatile in that regard. So these all mean the same thing in terms of logs and exponents. Now in some of these problems that we're going to do, you need to apply log properties first to combine several logs together before you go ahead and use our other solving techniques. So here we're going to notice that we have log base 2 in 2 places, and there's a minus in between. So those can be written as a quotient. So we would say log to the base 2 of x plus 5 divided by x minus 8 is equal to 3. So then we would raise up by the power of 2. So we would say 2 to the log base 2 of x plus 5 over x minus 8 is equal to 2 to the 3rd power. So that allows us to cross this log off here. So we've gotten the x's in a position where we can solve. 2 to the 3rd power is 8. So we can just do a cross product. X plus 5 is equal to 8 times x minus 8. So we have just a linear equation here that we're solving. So we're just going to go ahead and solve that linear equation. So we've got minus 5, so we've got x is equal to 69/7. So in this example, we applied a log property to help get us into a easier form to solve. So the first thing that makes sense to do on this problem is to take the 6 and bring it out front using the power property of logs. So I can say 6 log to the base 5 of x is equal to negative 2. Alright, so then I can divide that 6 out, and we'll have the log by itself here. All right, so now I can raise everything by the base 5 to get that log taken care of. So I'm going to have, cross this out, I'll have x on the left is equal to 5 to the 1/3, bring it down into the bottom, right? Get rid of the negative. Or we could write that as x is equal to 1 over the cube root of 5. So either of those two ways is a reasonable way to write this answer. Okay, in this equation we have a squared term here. All right, so this might be a little bit more work, but notice that we have a log 3 here and a log 3 here. So if this is a minus, then we could write this as a quotient, so that would be the first thing to do. So I'm going to say log base 3 of x squared divided by x plus 1 is equal to 2. And then I want to get rid of that log base 3, so I'll raise everything up by base 3. So I'll say log base 3 of x squared over x plus 1 equals 3 squared. So that allows me to cancel out this part. So I'm left with x squared over x plus 1 is equal to 3 squared, which is 9 over 1. So I can do a cross product here. So I have x squared is equal to 9 times x plus 1, or x squared is equal to 9x plus 9. So this is a quadratic that we need to solve. So we need to get everything over to one side and set it equal to 0. Okay, we're going to have to use the quadratic formula on this because it's not factorable. All right, so let's just make sure we have enough room. I'll divide my page up like this. So I'm going to use the quadratic formula, which you guys know by heart, I'm sure, by now. So I'm going to say x is equal to negative b plus or minus the square root of b squared minus 4ac divided by 2 times a, which is 1. All right, so we're going to simplify that. So we'll have 9 plus or minus the square root of 81 plus 36 over 2. 9 plus or minus the square root of 117 over 2. All right, so now I'm going to go ahead and plug these into the calculator so I can see whether I'm in the domain, which means, remember, the domain of a log. Let's just make a note here. Okay, so what we know about domain is that this inside part here has got to be greater than 0. All right, and we discussed why that has to be the case multiple times. So in order to be within the domain of this function, x is going to have to be greater than -1. So you want to check your answers here to make sure you're in that range of numbers. So I've got 9 plus root 117 over 2, and I've got 9 minus root 117 over 2. And I'm going to take that out to 4 decimal places using my calculator. All right, so I'm going to look at those numbers. Now this one is definitely greater than -1, and this one is definitely greater than -1. Remember, greater would be to the right of -1. So both of these x values are within the domain of this log function, so these are the two solutions. So it is possible that you're going to have to solve a quadratic if you're left with an x squared term in your simplified equation. All right, and then you check those to make sure they're in the domain, and you choose the solution based on that. Okay, so our next example says 7/6 log to the base 4 of x is equal to -1. So let's isolate that log base 4 of x. So we're going to multiply both sides by the reciprocal. So we'll get log to the base 4 of x is equal to negative 6/7. Now we're going to raise everything by the base 4 to undo the log base 4 to get to the x. So this is 4 raised to the minus 6/7 power. All right, so that gets rid of this, it undoes the log. So we've got x is equal to 4 raised to the negative 6/7 power. So it's generally not good form in math to leave your negative in the power position like that. So let's bring that 4 to the 6/7 power down to the denominator and make that positive. Or we could write it in root form, which would be 1 over the 7th root of 4 to the 6th power. So either of those ways is good form. So we're done with that one. So let's solve this one here. First we want to notice that we can combine these two log base 7s together using one of our log properties. So minus, of course, is related to a quotient. So we're going to set this up as a quotient. So we've got log to the base 7 of 4x squared divided by 4 is equal to 4. So canceling out those 4's, I would have log base 7 of x squared is equal to 4. So now I would want to undo the log base 7 by raising by the base 7 to undo the log on both sides. So now I can cancel that out, and I have x squared is equal to 7 to the 4th power. Now, whenever you're solving a quadratic, you've got to consider that you've got the plus or minus. All right, so if I want to solve this, I would take the square root of both sides, and I would get x is equal to plus or minus the square root of 7 to the 4th power. All right, now let's write that a little differently. Let's write it so we can take advantage of what we know now about rational exponents. So that's also x is equal to plus or minus 7 to the 4th power written with a rational root, like that, a rational exponent, I should say, which indicates a square root. So that's the same thing as x is equal to plus or minus 7 to the 4 times 1/2, which is 2. So this is x is equal to plus or minus 7 squared, and we know that 7 squared is 49. So this is really plus or minus 49. Okay, now let's check and see if that's either, if that negative 9, which is what we're a little concerned about, whether that's in the domain. All right, so looking at the domain here, it's squared, so it shouldn't be a problem. So 4x squared has got to be greater than 0. So you can see if you put a negative number in here and square it, you'll get a positive number. So we don't have any problem with domain here. So we've got two solutions. X is equal to plus 49 and negative 49. Okay, here's another example, and you're probably noticing that the theme of this lesson is that sometimes you've got to use properties to simplify your equation before getting rid of the log. So we're going to have to do that again. We've got a minus here. So these are related by division. So we've got log to the base 5. So I've got log to the base 5 of x divided by x minus 5 is equal to 1. So now I can raise both sides by base 5 to undo the log. So I can cross out my log, so I'll have x over x minus 5 is equal to 5 over 1. So I'll have 5 times x minus 5 I'm doing a cross product, of course, is equal to 1 times x. So that's 5x minus 25 is equal to x, which is just a linear equation to solve. So I'll have 4x is equal to 25. So x is equal to 25 over 4. Now let's check and see if there's any issues with the domain. So that's 25 over 4. Okay, so I'm checking to make sure that I don't get any negatives and have a domain restriction here with 25 fourths. So 25 fourths is 6 1/4. So 6 1/4 minus 5 is still positive. This one, of course, would be positive. So that is within the domain. 25 fourths is within the domain. So that is our answer. X is equal to 25 fourths. Okay, so we got this example. Solve the equation log x plus log x plus 1 is equal to 6. So these are log base 10 since the base is not written. So these are going to be related by the plus sign here. So we're going to create a product to simplify our log. So we've got log of x times x plus 1 is equal to 6. All right, so that's the same thing as log of x squared plus x is equal to 6. So in order to undo the log, we're going to raise everything by base 10. On both sides, so that's 10 to the 6th. So that allows us to cross this out. So we have x squared plus x is equal to 10 to the 6th power. That's a quadratic. We need to move everything over to one side and set it equal to 0 and use the quadratic formula. All right, so let's set that up. So a is 1, b is 1, and c is negative 10 to the 6th. So I've got x is equal to negative b plus or minus the square root of b squared minus 4 times a times c divided by 2 times a. So that's the same thing as x is equal to negative 1 plus or minus. So I'm going to plug that into the calculator, and I'm going to get square root of 4 with 5 zeros and a 1 divided by 2. All right, so that's two numbers separately written. So we're going to do, let's just simplify that to a number here. Square root of that 4,000-ish number, whatever that is, we're going to get this 0.000. And I'm retaining 5 decimal places on that number for accuracy. All right, so this is two numbers. Okay, so the first number is negative 1 plus 2,000 blah, blah, blah divided by 2. So that's 999.5001. The second number is negative 1 minus 2,000 blah, blah, blah divided by 2, which is negative 1,000. Okay, so let's check and see whether either of those two numbers are in the domain. All right, so back up to the top, what's our domain? So we've got two situations to check. X has got to be, for the first one, greater than 0, and x, for the second one, x is greater than x plus 1. Wait a minute, hold on. X plus 1, is greater than 0. All right, so that means x is greater than negative 1. So 0, negative 1. So we would say x has to meet both of those conditions, greater than negative 1 and also greater than 0. So everything over to the right of 0 is within the domain. So that just tells you x has to be a positive number. All right, so this is our domain calculation here, which you need to check. So let's go back down here, look at our numbers. So only the positive number is going to be in the domain. All right, so this one is not in the domain, so it can't be a solution. It's an extraneous solution. Okay, so that takes care of all of our examples. What you want to make sure that you do is if you're in a situation where you're reporting a decimal number that basically is not easily written as a fraction or an integer value, you want to retain four decimal places to the right as a rule of thumb. Okay, so we should be ready to tackle our homework set for 6.4. If you run into any problems, let me know.